Okay, so graphing quadratic functions. Sounds real complex, but it isn't really. A quadratic function is just something that has x squared in it. So it's not lines, they're going to make these curves. So when we're doing a standard form of a quadratic function, and this is one of the things that's on your formula sheet, it sets up like this. And that a, b, and c value are just numbers. They're coefficients that are in front of each of those values. A is always going to be the number in front of x squared. B is always going to be the number in front of x. And c is going to be the number that hangs out on the end by itself and doesn't have a variable. Okay? So, what's this going to look like? Well, one of two ways. Our shapes are going to be these funky U shapes. But they actually have a name. We're not just going to call them funky U shapes that open up or down. Anybody know what those U shapes are called? Parabolas. Ooh, I've got more people this hour that knew than before. Okay. So these are called parabolas. So from here on out, no more U-shaped thingies. They are now deemed parabolas. And there's a lot of similarities with these and absolute value functions we were doing before, the V-shaped ones. Because again, before, we knew that it was going to open up if our A value was positive. If the number in front was positive, it opened up. If it was negative, it opened down. Well, that's the same thing with these. If that number in front of x squared is positive, it opens up. If that value in front of x squared is negative, it opens down. Just like the absolute value equations. Also, we called it stretching then, but it also got wide and skinny or wide and thin based on something else. That also has to do with our A value. If our absolute value of A, which means it can be positive or negative, is less than 1, typically this will happen when there's a fraction in front of your x squared, like 1/2 or 2/3 or 3/4 or something like that. Your graph's going to get wider. Your U is going to get wider. However, if that value is greater than 1, 2, 3, 4, even -2, -3, again, because the absolute value, it's going to get bigger. It's going to get wider. No, thinner. Oh, Harty. Yeah. Draw myself a picture so I can make my words connect here. When my value is greater than 1, absolute value-wise, it gets thinner. So please pardon my issue there. And it gets wider, and I just happen to use a down one here, if that value is a fraction. And we'll talk more about that as we get a little further into these. And then we have a formula for finding our midpoint, or the center of our graph. And that formula is x equals -b over 2a. And that allows me to find the x value of my vertex, of the center point of my graph. But you're like, well, wait a minute, if it's a point on a graph, don't they have to be x, y? They do. So to find the y value, we're going to substitute the x value into the function, into the equation, and solve for y. So basically, we're just going to be doing some base substitution. So, I mean, let's just say, for example, while you're jotting that down, we found out that x equals 2. All I would do in any of these expressions down below is plug in a 2 where the x is, and whatever number comes out would be my y value, and I'd have my vertex, or my center point. And then I'll make a table for the rest. I will warn you, standard form does take the longest to get through. There's probably 3 steps we got to play with here. But they all won't be this way, so don't panic if we get into the middle and you're like, dang, that's a lot of work for one question. Well, they're not all going to be that way, but some of them will be. So here's how this is going to work. The first one, I'm going to do everything by hand. I'm going to use the calculator very little. 2, we're going to kind of blend them together, and 3, we're going to go all calculator. So I want you to be able to see how all these options are available to you. Okay, so standard form. first things first. I need to know what my A, B, and C values are because, well, I need to be able to plug them into my formula. So what's my A value in this first expression? 2. Okay, so my A is 2. What about B? Negative 4. And we don't need C in this case. We will down the road, though. So we'll go ahead and we'll get it labeled 2. So once I have those, my job first is to find the vertex. So to find my vertex's x value, I follow this formula, which is negative b over 2a. So the opposite of b, the opposite of negative 4 is positive 4 over 2 times a, 2 times 2, which is also 4. Okay, so the x value of my vertex is going to be 1. But again, a vertex is a point, so I still have to figure out what y is going to equal. So here's how I do that. I'm like, oh, here's y equals. So I'm going to go through, and every time I see an x, I'm going to replace it with my x value that I just found, which is 1 in this case. And I like to use parentheses no matter what number I plug in, because sometimes when it's a negative, that'll help me from making some errors. So I'm going to go ahead, get that set, and if you want to at this point, you could go to a calculator to try and clean this up. If you're worried that you might press a button wrong or you might do some mental math mistakenly, that's okay. And that's what I'm going to go ahead and do here. If you can do it in your head, that's fine. Make sure everything's typed in right. Got my parentheses. Okay. So for this problem, my vertex is at 1, 1. This point right here is going to be the centerpiece of my graph. You're like, okay, well, how do I get the other values so I can get this figured out? I'm glad you asked. Whatever my vertex is always going to go in the middle of my chart. Now, typically I tell people you want 5 points on this. You can get away with 3 sometimes, but if you make a mistake, you're not going to know. So once I get that value in the middle, I want 2 values that are greater. So typically I just keep going up by 1. So if I go up by 1 from 1, I get 2, and up another one's 3. But I also want 2 that are less. So I subtract 1 back each way as I'm making my chart. Now some of you are already looking at this going, so you're telling me I got to do the substitution thing 4 times on every problem? Nope. You're only going to have to do it twice, and here's why. One cool thing about parabolas are they're symmetrical. Okay, they're the same on both sides. So these values that are an equal distance away from my center, like 0 and 2, are both going to get the same answer. So I only got to plug one of them in and I get both answers. Or if I plug in negative 1 or 3, I'm going to get the same answer. So really I only got to do this twice. And I always use the numbers that I think are going to be easy. 0 is a prime candidate every time to get used, because what's anything times 0 is just 0. So like if I plug in the 0 here, well, that's 0 minus, oh, that's 0. So 0 minus 0 plus 3. Oh, I like this. Which is 3. Which also means the 2 is going to be 3. And if you don't believe me, we can check quick. So if I want to make sure that that really is going to come out 3 and that I'm not just, blowing smoke here, okay, now it's even proven. So you're like, well, I only took 10 seconds. I'm more comfortable actually plugging it in. That's fine. Given a choice each time, I'm always going to take the positive number to plug in though. So for my 3 and negative 1, I'm going to use 3. And again, I'm just plugging it in to this equation over here. Again, I like the parentheses. That way there's no question on what's going on here. Okay, so that comes out 9. And I'm going to trust myself. So I'm going to assume my other one's going to be 9. If my vertex is a whole number, this is the easiest way to go as far as manually would go. So I can plot my points. And if I plot my points correctly, I should notice that my graph is going to basically look symmetrical. And again, I'm trying to get a curve going here. These aren't the V's like absolute value. They're parabolas. They have some curve to them. So you're like, okay, I might be able to handle this. So is that it? For the most part, it is. Okay, so my vertex, I already did that up above, but I'll just rewrite it here, is 1, 1. But then you see what's below it. You're like, what's this stuff? Axis of sim. Stands for axis of symmetry. Here's the easy part about it. It's always going to be x equals because it's always a vertical line. And it's always going to be the x value of my vertex. So once I know what the vertex is, I know what the axis of symmetry is. And what the axis of symmetry is physically, and I'll actually draw it in on this first one so you can see how this works. If you were creating a foldable and you drew this axis of symmetry in, and then I picked up my paper and folded it along the dotted line, both halves of my graph would look the same on both sides because it's symmetrical on each side. So that's why these things go hand in hand. It goes through the center point of my graph, the vertex, but if I were to fold it over, I'd have equality on both sides. This is as long as it gets. And it's not terrible, but is there a faster way? Maybe. And if something kind of goes, you're kind of like, as we get into this next one, let me know and we'll try to take care of it. Okay, we're going to find our vertex x value on our own on this one. And then we're going to go back. So let's see here. Let's get our a, b, and c taken care of. So my a, it's a fraction. -1/2. My b is 1 and my c is 4. Okay, so here's our deal. We are going to find our vertex x value manually. So let's see. -b, so -1 over 2 times a. Now, let's think about this for a second. What's half of 2? You're like, hang on, we're writing 1. So 2 times -1/2 is -1. And it's one of those things, as long as I'm watching my details, you're like, really, the x value is 1 again? What the heck? Here's the part where I'll show you where the calculator might make life easier on us. So we just figured out the x value of my vertex is 1. Okay. Here's how we can go about making this a little simpler if we've got the graphing calculator. Now, we've already seen we can do it without it, but if we want to, I can say, okay, I'm going to plug this in. Oh, I'm sorry. Yes?
What is that saying for the equal sign?
This right here, it's just the vertex, and I'm finding my x value. Yep, just looking for that. So once I find this, I go, okay, I'm going to plug this in the calculator. Now me, I like to avoid plugging in fractions whenever I can. So I know 1/2 is really 0.5. So really it's -0.5 x squared plus x plus 4. Okay. And again, if you use the fraction, that's okay too. Just put it in parentheses if you do that. So I'm just curious. I want to see what it looks like. So I'm going to look. Okay. It opens down, which makes sense. My a value is negative. Okay. So how is this going to help me get this table done so easy? Well, if I go to second graph and I get the table, I want my vertex to be in the middle of my table. So wherever the 1 is, okay, that's right in the middle of my table. And notice what happens. Not only am I given my y value right there, but I also notice the symmetry that's involved. If I start going out from the 4.5, you notice above and below it, I have a 4. And then if I go another step out, I have 2.5 above and below it, and 0. If you have found the vertex, you'll see that symmetry in your table. And at that point, life's great, because I'm just going to copy those values that are around there, so I can get those. I can get these, and if I wanted to put in the -2, 0, and the 4, 0, I could. But instead of me having to plug them in and figure it out, I can do it a little bit faster. I mean, it's not the perfect thing, but it does make things a little bit easier. So I can plot my points. And there goes my curve. So notice I still found my x value by itself, but I didn't necessarily have to do it all on my own that way. So we again know our vertex is at 1, 4.5. And what's my axis of symmetry going to be this time? What's that?
1.
Yeah, it's going to be, I've got to put the x equals, but yeah, x equals 1. Because that's the point, or that's the line at which I could fold my graph in half and have symmetry. So there's lots of ways to be able to get this done. And again, this is probably, for right now, what I would suggest the farthest going as far using my calculator would go. There is a way to find your vertex using the calculator, but right now, I think getting too far ahead of things with some of you at this point would be more of a hindrance than a help. So what we're going to do, I'm going to swing my calculator over here. Let's do it the same way that we did in number 2 one more time. So again, for right now, even if I just know my a and b values, I'm going to be in pretty good shape. So 3 and 2. So to find my x value, one more time here, I'm going to do negative b, so negative 2 over 2 times a. So it looks like negative 2 over 6. So what's negative 2 over 6 reduced to? Yeah, negative 1/3. You're like, ooh, a fraction. Now, how exactly are we going to deal with that? Because that doesn't sound like that's going to be something too fun to play with. Well, there's going to be some parts of this that we don't like, but we'll make this work. So once I've got that, I go back and I'm like, okay, I'm going to type this in. 3x squared plus 2x minus 5. All right, so let's look at my chart. Now I look at the chart and I go, well, wait a minute. There's no fractions on here. How am I supposed to do this when there's no fraction? How am I going to get my y value? I don't know what's going on. Okay, you have a couple of options here. The first thing I'm going to tell you is negative 1/3 is between 0 and negative 1. Okay? So even though this is going to seem a bit odd, if my negative 1/3 is right there, I'm going to use the 0 and the 1 moving ahead, and I'm going to use the negative 1 and the negative 2 behind it to try and get my values. Now, some of you, again, at this point, as you madly write, may be saying, well, wait a minute, though. You keep talking about this symmetry. Those numbers aren't the same. And you're right. So in this case, if I can't get to my vertex this way, we are going to go old school. I'm going to go back and I'm going to type in, so here's my value, and I'm going to type in that negative 1/3. And this is something I can do on any calculator because, well, we just can. As long as I'm putting my x value in parentheses, I should be okay. Now let me make sure I got it. So 3 times negative 1/3 squared, yes. Plus 2 times negative 1/3, yes. Minus 5, all right. Now, if you want to put the decimal, you can. I don't have an issue with that. Negative 5.33, you could call it negative 5 1/3. I'm fine with that too. Now when I go to plot these, like I said, I'm going to be a little bit cautious because I'm not going to quite get the symmetry that I want. But again, we're not in this going for perfection. We're doing this kind of trying to understand how all of these are going to fit together. Because you're like, well, that's kind of weird. I mean, it's kind of... And again, I don't want to make some V shape. So I remembered, well, this is my vertex. So I'm going to start from my vertex, and I'm going to connect the dots as best I can to make something that looks more like a parabola. And then again, my axis of symmetry will still be whatever the x value of my vertex is. That's still going to be my point that cuts my graph in half. But if that's the worst thing that happens to us on one of these, that I got to do a little extra calculator play, that's okay. But the calculator, when it does come out nice for my vertex, kind of is nice to play with the tables. But this is the longest ones that we get into. They will not all be this long. A lot of the times we're going to get the real short ones to work with, and we're going to like those a lot better.
How did you get 5.33?
Oh, let me pop the calculator back up here. Basically, I took that negative 1/3 that I got from my x, and I plugged it in each of the places that I had x. So I had 3 times, and then I just stuck the negative 1/3 in for x. And that's where the negative 5.33 came from. But like I said, this is the trickiest one. This is the most work. The simplest one, thankfully, is the one right below it. Now, vertex form, this should look kind of familiar, again, from when we did absolute value graphs. These, I can steal the vertex right from. Oh, yeah. It's the opposite of this number, and I keep this one. Oh, yeah. So my vertex here, switch the sign, keep the sign, is negative 1,3. I don't have to do x equals. I don't have to plug it in. It's awesome. So negative 1,3. Boom. I also know my axis of symmetry. X equals negative 1. Again, awesome. So now, where am I going to get my other values from? Well, again, we have a choice. You can either do a chart like we did before and just plug numbers into your calculator. And again, that's never a bad idea. So like if I have negative 1,3, what would be a couple of values greater than that I might use?
0, 1.
Yeah, if I keep adding 1, negative 1 plus 1 is 0, plus 1 would be 1. And if I go the opposite way, maybe I'd use negative 2 and negative 3. But just keep reminding yourself, I don't have to plug all of these in. These two guys would be the same. And so would these two guys. So I might look at this and I might say, okay, well, we always say we like 0. So if I plug in 0, 0 plus 1 is 1. Or I could go to any calculator. Again, it doesn't matter. You've got to figure out what works best for you. Let me clear the rest of this. So that'd be like negative 0.5. And then I'd be like, okay, so I plug in the 0 for x. So it'd be 0 plus 1 squared plus 3. All right, I got a fraction. I can handle that. And that's going to set me up for 0 and negative 2. And then I look at the next one. And I'm like, you know what? I don't even need the calculator for this one. 1 plus 1 is 2. 2 squared is 4. Half of 4 is 2, so it'd be negative 2 plus 3. And again, if you want to use the calculator with that, you can. There's no rules against it. There's not like a calculator police that's going to come find you. So once you get those and I see the symmetry, I go, okay.
Great. That's great.
So what I'm going to do in that case is I'm going to go ahead and I'm gonna, just to be sure, once I plot these, and it kind of lets me show you too what can happen with some of them. All right, let me get my points plotted here as I'm going into speech mode here. Get my curve, I'm feeling good there. Because some of you may be saying, well, why didn't you just do it on the calculator? Well, I could have. I absolutely could have done negative 0.5 x plus 1 squared plus 3 second table. Because what value do I want in the middle of my chart? I want negative 1 in the middle, and check that out. There's the 2.5s that we found. They're the ones that we found. So the table works for this if you have the graphing calculator available. But it doesn't mean if you don't have a graphing calculator you can't do it. Will it take a little longer? Yes. But is it impossible? No. Especially when there's no fractions involved with anything. Now, some of you may even go so far as to say, hey, I could even save myself a little more time. Now, I don't really think we need it on these, because what's my vertex going to be in number 5? 2, -4. So I'd say, okay, even if I want to make this go fast, at least if I know what the vertex is, I'm going to know where I want to put the middle of my graph at. So I'm like, okay, I need, oops, going the wrong way. I want my x value of 2 in the middle. There's 2, -4, just like I figured out. And now for the rest of it, well, shoot, I'll be perfectly honest, I don't even think I need to write the other numbers down. I'm just going to plot them. So let's see, 4, 0, 3, -3, 1, -3, 0, 0. And my axis of symmetry is just the x value of my vertex, and I'm done. And again, that even wouldn't have been real tough to do if I would have made myself a chart. I always like showing you both ways of doing these things, but at the same time, you know, I want you to be able to do them on your own too. All right. Yeah. Oh, okay. Let me go back here. Because again, on these, yeah, let me just bring that back up. So, as we're getting those, and actually I'm just going to shift my calculator over this way a little. I'm going to start looking and being like, okay, I'm to a point that I'm feeling really comfy with this. So -3, 1. Okay, I can get my vertex. So I know the center of my graph is going to be right here. Now again, is this something where I really couldn't just do this on my own and not even use the calculator? I say you can do this on your own. Because I take, again, 2 numbers that are less, 2 numbers that are greater. And remember, I only got to do 1 for each of these. So here's the cool thing. So let's say I say, okay, I'm gonna be brave here. Okay, -2. -2 plus 3 is 1. 1 squared is 1. 2 times 1 is 2. Plus 1 is 3. And that takes care of 2 of them. And that took me like 7 seconds, maybe. But again, just take your time. And it makes you work your mental math a little bit too, which is a good thing for when we're factoring and breaking down roots and stuff. -1 plus 3 is 2. 2 squared is 4. 4 times 2 is 8. Plus 1 is 9. And again, I can get it from the calculator. I could plug those into that number and plug them in the calculator, whatever you need to. But I just like getting the practice, and it also lets me see the symmetry. So then when I plug the rest of these in here, my axis of symmetry is just the x value of my vertex, and I'm good. So calculator, no calculator, we know how to do it all. Now there's one more form. So we've done the really long form. We've done the really short form. Now we're going to do kind of the in the between. So, let me flip her over here. Get my calculator back out of the way. Now the last form is intercept form. So when we find intercepts, we notice back up at the equation, ooh, there's no b, so I can't use the formula. We're not going to need it. But notice to get my intercepts, it's the opposite of p and the opposite of q. So when I'm doing my intercepts here, I just take the opposite signs of what I see. And those are literally 2 of my points. There's a point on -3, and there's a point on 5. You're like, okay, but how do I find the vertex now? Well, you have 2 options. There's a formula for this, If you remember midpoint formula from geometry, basically that's what I'm going to do here. So if I'm looking for my vertex, I could take my two intercepts, add them up, and divide by 2. If you're going to do it on the calculator, you need to do one of two things. You either need parentheses around these, or you need to do the -3 plus 5 first, then divide by 2. Because let me show you what happens if you don't do that, because we had an issue with that in one of my other classes. They just did -3 plus 5 divided by 2, and then when they said it was -0.5, I said no. They're like, well, that's what I typed in. I said, but the calculator does what you tell it to. It did 5 divided by 2 and then added it to -3. Like, that's not what I wanted to do. I know that's not what you wanted to do, but that's what you did. So, like I was saying, if you want to do it on the calculator, you either need to use the parentheses or you need to do each step separately, like if you were to do it like this, okay? So my vertex x value is -1. Oh, no, it isn't. It's +1. Crazy man. Can't even read the calculator right. Well, then how do you find y? Just like we did before. So now what I'm going to do is I'm going to plug that 1 in for x in each of my sets of parentheses. So 1 plus 3 is 4. 1 minus 5 is -4. So 4 times -4 means my y value is going to be... What's that? Right, but I'm not, I do the opposites to find my intercepts, but when I'm literally plugging in for y, I'm still just plugging in literally what it is. Good question. So my vertex being at 1, -16, whew, that's a trip. It's still going to be my same value for my axis of symmetry. It's going to be my x value. And there's no tables or anything to do here, and we're really only going to get 3 points. We're going to get our 2 intercepts and our vertex, and we're going to be done. One last one. Because the application we're going to hold off on for right now, because I want to make sure we got the basics with this. And I want to let you in on what we're going to be up to tomorrow, too. Okay, so one last time. What are my x-intercepts going to be for number 8? 1 and -3. Okay, so 1 and -3. Now I could, and I didn't even mention this in the last one, I could just use my fingers or a writing utensil to figure out what point's in the middle. And if it comes out as a nice number, that's a good way to do it. I just keep using the formula because it works for everything. So here I'd have 1 plus -3 divided by 2. So let's see, -2 divided by 2 is -1. So that's my x value of my vertex. Be careful when you're doing the y part, especially if you're doing it on the calculator. Don't forget about that negative that's out front. So I'd have -1 minus 1 in my first set of parentheses, and I'd have -1 plus 3 in my second one. Because that negative, the product's going to be negative, but this will turn it back to a positive.
Where did the -1 come from?
This one?
Oh.
Yeah, it's just the midpoint of my 2 intercepts is where that -1's coming from. Because like we noted up there, I even could do this and go, okay, I'm counting in. Oops, my points came together. What point am I at? Well, I'm at -1. That works. Because then I could go -1, +4. I know it should be opening down because it's a negative a value. Get my parabola in there. And my axis of symmetry, again, just is the x value of my vertex. It's my foldable line. So here's our game plan with this, because I don't want to go overboard the first day of things. So I'm going to bump this up a little bit here. Okay. Our first assignment for homework check 7. And some of you that get curious, homework check 7, we're probably looking at the end of next week, like Thursday, Friday. It's going to be on page 253, 20 to 36 even. They're graphing with these. There's 8 graphing problems, and they're evenly spread out as best as I can with the 3 different types. That's why you got the graph paper from up there. So tomorrow, we'll talk a little bit more about this. We're going to have a sheet where we get some more practice with these, and we're also going to work a little bit with breaking down roots, because that's going to be what we're doing next. So there will be no new lesson tomorrow. It'll be kind of like a work day of sorts, but you do want to at least try one of each of these in the homework tonight, or you will forget how to do it. Just saying. So please do that.